Solving systems of linear inequalities. When we work on solving equations, first of all, I need to graph this guy to find a point that they might share in common. I'm going to change this to be 2 and 4, negative 2, negative 4, 2 and 4. And here my y-intercept is 2, so I'm going to go up 2. And my slope is 1 over 1. So I'm going to go up 1, right 1, up 1, right 1. And I'm going to connect that. So there's that line. My second line, my y-intercept is 1. And then I'm going to come down 2 into the right 1. And I'm going to connect that line. And I see that they share a point right here. But what my paper asked me to do is to change the first one to be greater than or equal to. So I'm looking at the purple, and I need to be greater than or equal to. Greater than is above, and so I have to shade because it includes all the things greater than that line. And then down here, they asked me to change my second one to less than. And this line, if we can get it to do it, should be dotted because it's not equal to here. Here it was equal to with the line. Here it is not. So I should dash that line. It's kind of hard to tell, but we did. And less than is lower or below. And so what I can see is this section right here is the place that has all the solutions to both inequalities. So what I'm going to do is practice this on the next page. On this problem, they already have it all graphed, but what I want to know is how come there's a dashed line and a solid line. So remember, when I see greater than or equal to, less than or equal to, I'm going to do a solid line. Now when I do less than or greater than, that's going to be a dotted line or dashed, whatever you want to call that. So here it is not equal to, so that's the dashed line. Notice the y-intercept is 0 because there is no y-intercept here. Okay, so the next example that we're going to work is this one right here at the top. So I'm going to do it in purple. The only variable I have is x, so I'm going to go on the x-axis to 3. 1, 2, 3. Again, I'm going to ignore these numbers. I'm going to make that 2 and 4. I don't want to count by 2s. I want to count by 1s. So I'm going to go on the x-axis at 3. It is going to be a dashed line because it's not equal to. And if I draw my line horizontally, x isn't 3 right there. It's not 3 right there. So I have to go through the x-axis. X is the only variable I have, and I have to go through it. Now it says x is greater. A number that's greater than 3 would have been 10. And 10's over here on the right. So I shade over there. My second equation is actually not ready to go. In order to get y alone, I will subtract the x, so it becomes negative x to get to the other side. So my y-intercept there is 2, and my slope is negative 1, so I go down 1 to the right 1, down 1 to the right 1. It's not equal to either, so I need another dashed line. And according to this line, we are less than, so I'm going to go below. And that one's kind of hard for you to see. And so you can tell that right here is my solution area. That is where the coloring overlaps. Number 2, this first equation is not in slope-intercept form, so I'm going to say y is less than, I'm going to move x by subtracting it. So now I can graph this, and my y-intercept, okay, and my y-intercept is 4. And again, my slope is -1, so I go down 1 to the right 1. And I am not equal. There's not a line there, so I'm going to go ahead and dash this line. And I want to be less than, that is less than, so I want to be below. And this line is ready to be graphed. So my y-intercept will be -2. And I'm going to go up 2 to the right 1, up 2 to the right 1, and I can see right there they intersect. On this particular line, I have it equal to, so I'm going to make it solid. And I am greater than my line. Greater than is above. This would be below, so I've got a color over here. And you can see your solution area happens to be all right here. The last thing that you need to know for this lesson is if you have a situation like this, and I've got to get it into slope-intercept, my first step is to subtract the 2x. So I have -3y. -2x and 6 are not like terms, so I keep them separate. Then my job is to divide by -3. And it's going to change the sign and change the sign. So I also have to change my inequality. I have to do the opposite. So the opposite would be less than y. I'm going to get a positive 2 over 3. And a positive divided by a negative is a -2. So don't forget that when you divide only, it doesn't matter what's in the numerator, it's what I'm dividing by down here. Whatever's in front of y, if it's negative, when I divide, the inequality sign flips. There are word problems that we assigned here, so you may want to come in and get some help with that.